Hello everyone, this is Deep. Uh, this video is part of my physics assessment quiz, and today in this video I'm going to talk about friction force. In this question, I have a regular guy called Mark who holds a 3 kg metal block against a wall, and by applying a sudden horizontal force, I am asked whether the block slips down the wall or not. So in order to solve this question, I have drawn a free body diagram, as you can see here. Here Fn represents the force exerted by the wall to the metal block, and the F grab represents the force of the earth, that is downwards, and F hand represents the force exerted by Mark's hand against the wall. So we have been given the mass of the metal block 3 kg, and the coefficient of friction, that is 0.4. Here the coefficient of kinetic and static friction is both 0.4, so we don't have to worry about that. And our systems are block, gravity, wall, and hand. Now, in order to solve this question, we know that from the momentum principle, the change in momentum is equals to the torque of net force times the change in time. So, to solve this question, I first divided the x and y component of momentum. First, we look at the change of momentum in x direction, and that would be 0 because since there is no net force acting on the block, that is since it is at rest, and it would be 0 here. But in the y component of the momentum, we have to be careful because we have frictional force acting on it. So we know that the product of the frictional force is mu k times F hand. And since the earth is pulling the block towards it, we have to subtract the product of the force, that is mg. And if this is the case when the block is considered to slide down, then we can use this equation here. So when we substitute and we combine these two equations, we get the same equation as the change in momentum of the block in the y direction, and after substituting the values, we get a value of minus 21.4 Newton times delta. At delta, it doesn't change the sign that we obtain here, and the sign here plays a very significant role. The negative sign in our changing momentum states that the force exerting on the metal block by gravity is greater. So what happens is that if the force exerted on the metal block by the gravity is great, the metal starts to slip down the wall. But if the change in the momentum were to be positive, then the object, it would not slide down the wall. So in this case, our block, it slips down the wall. So that's the answer here. I hope you like this video, and I hope you find this very useful. Thank you.